I'm not sure if you're aware of it, but Australia has a very smelly problem: waste and how we deal with it. This issue is rooted in the mismanagement of waste alongside the current paradigm of out of sight, out of mind. Combined with this attitude, single-use plastics are having a disastrous effect on the well-being of our planet, and bioplastics have sprung forth as a supposed solution. Bioplastics are a special category of plastics made from plants or other biological material, as opposed to their petroleum-based counterpart. It is well known that bioplastics can be biodegraded, but it is less known that they require special treatment in order to do so. Most people are unaware, but bioplastics are actually non-recyclable, and when they are disposed of as such, it causes the whole recycling stream to be contaminated and sent straight to landfill. This poses a huge problem, and if allowed to continue, bioplastics will do more harm than good. One of the UN's Sustainable Development Goals is to reduce the ecological footprint of production and consumption patterns within society. Bioplastics seek to serve this goal by limiting the environmental impact of our disposable products. And while we don't want to promote a culture of disposability, it's important that we have systems set in place that can mediate the waste produced in this day and age. And until there is an even greener solution, bioplastics are a step in the right direction. Food waste is another issue we've decided to tackle. According to the UN, 22% of greenhouse gases heating our planet are caused by food waste. How? Because when it ends up in landfill, it breaks down and releases carbon dioxide and methane straight up into the atmosphere. Our project aims to tackle the mismanagement of food and bioplastic waste while disseminating how bioplastics can and should be treated in a way that is interactive and accessible. This issue is of significance all around the world, but we have decided to target our campus at the University of Technology, Sydney, to create a model system that can be adopted anywhere. In 2019, UTS opened its newest building, which boasts a plastic-free food court. This food court employs bioplastics, primarily PLA, a bioplastic derived from cornstarch, as well as other materials such as bamboo, paper, and aluminium as sustainable alternatives to plastic packaging. This is a perfect opportunity to teach people that bioplastics alone aren't a silver bullet solution, but more an improved material that must be treated with an updated etiquette, one we wish to demonstrate.
Introducing the DigeStation. With this vessel, we'll be able to break down both food and bioplastic waste on campus. Most importantly, we'll be doing so in a way that involves and educates the public. The DigeStation engages with students through a return and earn system, some data screens, as well as an inbuilt barbecue utilizing biogas that it itself produces. Through the natural process of anaerobic digestion, our design will break down organic material and in return create digestate as well as biogas. This gas is composed of approximately 60% methane and 40% CO2. Methane is a flammable gas which can be used to produce heat and electricity, while digestate is a nutrient-rich, liquidy substance which can be used as a green alternative to synthetic fertilizers. We've designed our digester to be central to our university's campus in an area known as the Alumni Green. This area has a high level of foot traffic and is a popular spot for students to enjoy their lunch, making it the perfect place for the DigeStation. UTS has over 130 clubs and societies that have sausage sizzles on the Alumni Green as a way to draw in new members or raise funds for the club. We've integrated a bio barbecue in our design, which can accommodate for and even improve such events. This barbecue runs off of the biogas produced in the digester and serves to encourage interaction with the DigeStation. It's a performative way for us to highlight to students the real positive impact that good waste management practices can have. So how is this digester going to work? The digester will primarily be made of concrete for durability and heat retention, having a volume of approximately 30 meters cubed. To bring people into the decomposition process, the DigeStation has a number of glass panels that allow people to watch the process happen. As a student comes towards the digester, the screens will display what can go into our digester, including food scraps, paper bowls, napkins, and PLA. These are then placed into the designated entry point and are scanned to ensure only correct products are entering the system. In order for the digester to function at maximum efficiency, contamination from non-compostable waste forms must stay below 5%. In order to do this, after the waste has been dropped off, it travels along a conveyor belt located inside the glass tube, where it passes through a near-infrared scanner. The scanner can get an accurate reading of the molecular structure of the rubbish in as little as 30 seconds to determine whether the waste is PLA or organic. If the waste is not appropriate for the digester, then it gets ejected here and is treated the same as the other waste on campus. The PLA and organic waste continues its journey along the conveyor until it gets to the entry point. Before entering the digester, the waste is shredded to reduce it to pieces 5 centimeters or less, an important step in accelerating the decomposition process. The digester is heated to thermophilic temperatures via a heating system that is powered by the biogas. The thermophilic temperature of around 55 degrees is suitable for the bacteria and ensures that PLA will degrade properly. And also, having a mixing arm built in ensures we have an even dispersion of heat, waste, and bacteria.
The process that occurs inside the digester can be broken down into 4 steps. These are hydrolysis, acetogenesis, and methanogenesis, which are achieved mainly by anaerobic bacteria. At each stage, the waste is broken down into smaller and smaller parts, with the final products being biogas and liquid digestate. Once the digester is functioning properly, it can take around 200 kilos of waste a day. The total decomposition time is around 14 days for organic food waste and around 40 days for the PLA. As the waste breaks down, gas will form and rise up, causing a pressure that opens the valve and releases the gas into the tank. Around 20,000 litres of gas is estimated to be formed per day. Part of this will be used to heat the digester and also run the bio-barbecue. This amount of gas equates to around 66 hours of sizzle time a day. But obviously this won't all be used up, so the remaining gas will be filtered and sent off to be used as a sustainable source of energy elsewhere. The liquid digestate will also rise and is to be emptied out through the tap located on the side of the digester. The tap is a filter to avoid any undegraded material from being extracted. This liquid digestate is composed of water and plenty of nutrients, so it will be used as a fertilizer around campus. The amount of digestate removed each week must be similar to the amount of waste that has been added to avoid overfilling. As mentioned, the digester needs to be functioning properly before large amounts of waste are added, and this is known as the startup period, where for 4 weeks, a gradual addition of organic waste and cow manure is added to the digester. This is to ensure the right bacteria is present and that the conditions are optimal for their growth and function. The digester will cost approximately 150 to 200,000 Australian dollars. However, once the system starts to produce sufficient amounts of biogas and fertilizer, these 2 products are valuable resources which can be sold on the market.
Our design is not only a sustainable way to manage waste, but it also educates students about waste and the unknown impact they may be having on the environment due to their waste habits. This will be done in a number of ways. Firstly, there will be a series of engaging posters placed around the campus. Then a screen that displays real-time statistics about the total amount of waste input and gas produced. Furthermore, on the top of the digester is a viewing window where students can look straight into the digester. To encourage interaction with the digester, we've devised a return and earn system whereby students can earn points that can be spent at the uni food courts. We've chosen to use the University of Technology Sydney as the location for the first DigeStation because as a place of education, we see this as a great place to begin to change people's mindsets around waste. We want to encourage people to be more conscious about where the rubbish goes and the impacts it is having. As bioplastic usage increases all over the world, it's important that we have systems in place, such as the DigeStation, to manage these materials properly. Otherwise, they are scarcely better than their non-biodegradable and petrochemical counterparts. We envision every shopping centre or food court and every community having a system such as this in place to reduce human impacts on the environment and reap the benefits of good waste management practices. As a group, we aim to shift the current mindset surrounding waste and develop solutions that will help move us towards a greener future. Let's change the waste
game.